Pde Unit. Okay. Now, students, listen. Today we are going to solve the problem Fourier transform under the function f of x equal to 1 minus modulus x. 1 minus modulus x under the limit of modulus x is less than 1. And also we are going to find the inverse form of Fourier transform. We need to show that the function 0 to infinity sin t the whole square dt. Okay. First taking the function f of x equal to 1 minus modulus x, then come to the Fourier transform formula. What is the formula for Fourier transform? F of s equal to 1 by root 2 pi integral minus infinity to plus infinity e power isx into f of x dx. In place of f of x, we are substitute the function 1 minus modulus x. So 1 minus modulus x under the limit of minus 1 to plus 1. Under the limit of minus 1 to plus 1. So after substitute the limit of minus 1 to plus 1. Now write the formula of e power isx. You know the formula for e power I theta, right? What is the formula for e power I theta? Cos theta plus I sin theta. So in place of theta, here there is a function s into x. So that expand the function of e power isx into the form of cos sx plus I sin sx into dx. Then in our next step, we split the formula for the cos x as well as the sin x. So that minus 1 to plus 1, 1 minus modulus x into cos sx dx plus I into the imaginary part of 1 by root 2 pi minus 1 to plus 1, 1 minus modulus x sin sx dx. So using the condition for the odd function, if the function under the limit of minus to plus, so 1 minus modulus sin sx is an odd function. So that answer tends to 0. So 1 minus modulus x into cos sx is an even function. So that 1 by root 2 pi minus 1 to plus 1, 1 minus modulus cos x dx is there. Thus portion tends to 0 because of the function is an odd function. Then come to the even function. For even function, the limit minus a2 plus a f of x dx is change it as in the form of 2 into integral 0 to a f of x dx. When if the function f of x is an even function, then we can write it in this form. So that here what is our limit? Minus 1 to plus 1. So we have to change this 2 into integral 0 to 1. So 1 by root 2 pi is there. Okay. So you have to change the 2 as root 2 into root 2 divided by root 2 into root pi. So what happened? The root 2 cancel. So that our answer is root 2 by pi here. Integral 0 to 1, 1 minus. The portion only there is a positive value. So instead of moduluses, you have to take the positive x only here. So that x is x into cos sx dx. So in our next step, we are using the formula u dv. There is a two function is there, 1 minus x as well as the cos sx. We can't integrate it directly because of x, so that we are using the formula integral u dv. What is the formula of integral u dv? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus and so on. So instead of u, we are using 1 minus x and the remaining portion is take it as dv. So what is the first term? U into v. So the first term 1 minus x. dv is the there is a dv. So if we integrate the dv, we get the value of v. What is the integration of cos x? Integration of cos sx is equal to, what is the answer? Is equal to sin sx divided by the coefficient of x, s. So the value sin s by s. Then what is the formula? Minus. There is a minus. So put minus and the differentiation of u. What is the differentiation of u? If you differentiate the constant term 1, that tends to 0, then the differentiation of x is 1. So the answer is minus 1. And again the second integration. What is the integration of sin sx? Integration of sin is cos. So minus cos. So minus cos sx, already there is a x. Now your answer is s square. So our answer is minus cos ss by x square. Then write the limit 0 to 1. Now apply the limit 0 to 1. First write the upper limit. Okay. On the whole of upper limit, if you substitute the upper limit 1 here, then 1 minus 1 is 0. 0 into anything 0. So for upper limit, the term first term tends to 0. What about the lower limit? The lower limit is 0. On the lower limit, sine 0 value. If you substitute x equal to 0, then there is a sine 0. Sine 0 value is 0. So for on the lower limit also, the first term tends to 0. So come to the second term. There is a minus into minus. There are 3 minuses there. So our answer is minus. Then replace x by 1. So the upper limit cos s into 1 is yes. So s into 1 is yes. So divided by s square. Then there is a minus. Minus into minus 1 plus 1. Cos 0. What is the value of cos 0? Cos 0 is equal to 1. So replace the value. The lower limit is 1. 1 by s square. Taking the denominator as common. So the numerator I did in the form of 1 minus cos s divided by s square. So now we get the answer for the Fourier transform. What is the value for Fourier transform? The symbol of Fourier transform is f of s. So the value of f of s equal to root 2 by pi 1 minus cos s by s square. One part of the problem is completed. Okay. Now come to the second part. What is our second part we need to prove? The second part is find the inverse Fourier transform. Inverse Fourier transform. For inverse Fourier transform, we need to show that the term, what is the term? We need to show that integral 0 to infinity sine t by t the whole square into dt is equal to pi by 2. The term we need to prove. For prove the term, first you have to take the formula for Fourier transform. What is the formula for Fourier transform? The Fourier transform formula starts from small f of x. Small f of x equal to 1 by root 2 pi integral minus infinity to plus infinity capital F of s e power minus isx dx. Sorry, dx. So now start to solve the problem. So now this is term equal to 1 by root 2 pi integral minus infinity to plus infinity. Replace the value f of s. F of s is the answer of Fourier transform. What is the answer of Fourier transform we get? 2 by pi 1 minus cos s divided by s square. Now expand the value of e power minus isx dx. What is the value for e power minus isx? As usual, cos sx minus I sin sx into the term ds. Already we know the function sine is an odd function. In the limit of minus to plus, the function is odd, that turns to 0. So that is that the second term tends to 0. What about the cos term? Cos term is an even function. So you can write the limit first start from 0. Okay, what is the constant term? One is that the constant term is 1 by root 2 pi. The another constant term is root 2 by pi. Now convert the limit minus infinity to plus infinity as 2 into 0 to infinity and 1 minus cos sx divided by s square into cos sx into ds. What is the value of f of x? The f of x is 1 minus modulus x. Already we know that that was given in our problem. Okay, now you start to simplify the value. For simplifying this, multiply the constant terms. Now taking x equal to 0. For substituting the value, taking x equal to 0. So what is the value for right side? Left side we get, finally we get 1 equal to root 2 and root 2 cancel. Then what is the numerator value? 2 divided by the denominator root 2, root pi into root pi is pi, integral 0 to infinity 1 minus cos s by s square into cos s0 into ds. What is the value of cos 0? Already we know the value of cos 0 is equal to 1. So that the cos 0 value is 1. Bring 2 by pi into the next side. Already that is a 1. So 1 into pi by 2. If we come to the next side, into the reciprocal, so our answer is pi by 2 is equal to integral 0 to infinity 1 minus cos s divided by s square into ds. So that sine 0 equal to 0. Now replace the value in place of sine 0. Then the final answer is pi by 2 equal to 0 to infinity 1 minus cos s by s square into dx. Okay, now come to the formula. Already we know the formula. What is the formula for sine square of x? Already studied 1 minus cos 2x by 2. So now bring this 2 into the next side. Our answer is cos. We need the value only for s. So that cos x equal to 2 sine square x by 2. So for replace the formula 1 minus cos s in place of 1 minus cos s. You substitute the formula 2 into sine square s by 2 into ds divided by s square. But what we need to prove, that is a term sine square t by t square. So taking s by 2 equal to t. Then this implies s equal to 2t, then implies ds equal to 2 dt. Now substitute all these formula in our last step. We get the answer pi by 2 equal to integral 0 to infinity 2 into sine square s by 2. In place of s by 2, replace the value t divided by, in place of s you have to replace the value 2t. Okay, so then 2t square, and in place of ds you have to replace the value 2 into dt. So now 2 into 2, the numerator value is 4, then denominator 2 square value is 4 into t square into dt. 4 cancel, then your final answer what we need, that is a proof 0 to infinity sine t, the t the whole square into dt equal to pi by 2. Thank you.